All right, so here's our lesson 9.3 on solving rational equations. So just like we've done with everything else to this point, the first thing that you want to do with anything is factor. So remember, we're talking about trinomials, GCF, difference of squares. The more you can factor, just the simpler you're going to make this problem for yourself. The second thing we need to do is talk about excluded values. So remember, excluded values are where your denominator cannot equal 0. Then you're going to solve, which is the kind of what we're going to talk about today, because this other stuff is old. And the last thing, which is actually new also for today, is checking for what we call extraneous solutions, which are solutions that we're going to get that are outside of our domain. So they're like undefined values, but we get them as solutions. And I'll show you what that means in an example or two here. So let me give you just kind of a strategy for what we're going to do today. Let's say you have the equation 2 over, just making up numbers, 2/9 plus x over 9 equals 7 over 9. And for them, I mean, you all know how fractions work. If they have the same denominator, you can add them. But if you have this equation, I feel like most of you could probably look at this and really quickly see, okay, well, this x must be 5. And the reason that you can do that very quickly here is because if all of these denominators are the same, then that almost means that we can kind of ignore them for a minute. It's not that they're not valid, but if they're all the same, then we're talking in the same kind of context here. So we can really just solve this equation, 2 plus x equals 7, and figure out that x equals 5. Okay, so we're going to use that same kind of philosophy to solve some of these questions that we're going to do in this video. Okay, so this is our first problem. Remember, the first step we need to do is factor. And in this instance, we really don't have anything to factor. These are all just monomials, just singular terms, so we don't really need to worry about factoring anything. The second step is to talk about excluded values. So those are going to happen anywhere we have an x on the bottom. Okay, so in this case, we're really just looking right here at this x that's by itself. And remember, when x is by itself, that just means that x cannot equal 0 itself. Obviously, I'm not worried about this 5 or 10 because those don't have variables with them, and 5 and 10 already don't equal 0 themselves. So just don't forget our excluded value up here. Okay, so now we want to solve. And remember what we talked about on that last example, that little intro problem. Our strategy would be to get the denominators all to be the same thing, because if we could do that, this problem would be a lot easier to solve. So I'm trying to think about, just like when we do with adding and subtracting, how do I make these denominators the same? And I see that this first one needs a 10. So if I multiply by 10 on both of those, that will make it 10x. And if I put an x on this last fraction and multiply by x on both parts there, now that denominator is 10x. So it's really just this middle one that I need to deal with. And if I multiply by, let me put a multiplication symbol. If I multiply by 2x, that's going to solve, fix that issue. So now I'm going to rewrite my problem. I've got 30 over 10x plus 4x over 10x equals x squared over 10x. And now my denominators are all the same, so just like in that example problem, I can almost ignore them and just pull this numerator to solve my problem. So I've got 30 plus 4x equals x squared. And now we're back to just solving this quadratic equation. I need this to equal 0. So 0 equals x squared minus 4x minus 30. And we're going to pick our two numbers. So multiply to negative 30, add to give me negative 4. Let me think about that. All right, well, that's a bummer because I can't come up with any numbers here. So now I'm going to have to do quadratic formula. All right, so x equals, and you may just want to pause the video and see if you can get the same thing that I can, or let it play and work while we're working. 4ac all over 2a. All right, I'm going to pause the video and simplify this, and I would like for you to please do the same. Okay, so this is 136 is 4 and 34. This actually isn't too bad after all. So that's going to lead me to x equals 4 plus or minus 2 square root 34 over 2. And remember my three-part fraction, so x equals 2 plus or minus the square root of 34. as my final answer. Now remember, step 4 in these is to check for extraneous solutions. So what I'm going to do here is check to make sure that these solutions I got are not part of the excluded values that I defined in the beginning. So I'm going to come back up here and check that none of what I got was this excluded value. And it's not. 2 plus the square root of 34 and 2 minus the square root of 34, neither one of those is 0, which means these are both solutions to my equation. All right, so here's our last example. Remember, we're going to start with factoring. So I notice a lot of these parts are factored except for maybe this denominator right here. So I need to come up with two numbers that multiply to 3 and add to give me 4, which are going to be 3 and 1. So this is going to be negative 2 over x plus 3, x plus 1 equals 4 over x plus 3 plus x plus 1. All right, now the second thing I need to do is to define my, or find my undefined values or my excluded values. So I'm looking here in the denominator and I see between all of these denominators, so you're going to look everywhere, I see that x cannot equal negative 3 or negative 1. And hopefully that's a fast process for you now. All right, lastly, now I'm going to solve. So I need to make all these denominators the same. And I see that this should be pretty simple. This middle fraction needs an x plus 1. So I'm going to put that on the top and the bottom. The last fraction is going to need an x plus 3. So I'm going to put that on the top and the bottom. Okay. So now I can see all of my denominators. I'm just going to highlight here so you can see all my denominators now match. And so just like we said before, the strategy is when that happens, now I can focus just on my numerator. So my problem now says negative 2 equals 4 times x plus 1 plus x times x plus 3. All right, so now I'm just working on solving this. Negative 2 equals 4x plus 4. I'm distributing plus x squared plus 3x. I notice this is a quadratic because it's got that x squared term, so I'm going to make this equal 0 and put it in standard form. So 0 equals x squared plus 7x. If I add the 2 over, that's going to be plus 6. So now I need to solve this. I need two numbers that multiply to give me 6 and add to give me 7. It's going to be 6 and 1. So 0 equals x plus 6, x plus 1. And I know I'm going kind of fast, but I feel like you all know how to do this, so I hope I'm not confusing you here. Now that these are factored, we can set them each equal to 0, right? That 0 product property. So that's going to mean that x could equal negative 6 or negative 1. Those are my two values. Now remember, your last step is to check for extraneous solutions. And this is actually a process we're going to do again with another type of function that we solve. So I'm going to look back up here, and I want to compare this to where I said my excluded values were. So my excluded values, I said x could not equal negative 3 or negative 1. But when I solved it, I got that x was negative 1, which is a problem. So that means in this instance that negative 1 is not actually an answer. It's what we call an extraneous solution. So I would label this extraneous solution. And be aware, because if this is multiple choice, I guarantee you negative 1 is going to be one of the options. And it's because they're trying to get you to pay attention to whether or not you can have those defined values. So the only answer in this final solution set is actually negative 6.